thank you everybody for making time today to hear more about how we can optimize Postgres with AI tools and MCP servers, and why we maybe shouldn't do that, or why we should do that. I'm Lucas Fittel. I'm the founder and CEO of pganalyze, which is a tool for Postgres optimization. Today, we're going to talk a little bit about, I want to make sure this is genuinely useful, whether you want to use our product or not. I'm also an engineer by trade, so I want to make sure that, if you are an engineer yourself, that this is useful to you, and this is not just me pitching you something. So let's make sure that I can, get to those goals. We have a Q&A section, so if you have any questions, feel free to put them in a Q&A. I'll do most of the questions at the end. We'll probably go for about 45 to 55 minutes. And then at the end, we'll take a few minutes for questions. If there are a lot of questions, we'll put them in a follow-up email. You'll also get the slides in a follow-up email tomorrow together with some resources. So all of that, feel free to ask questions, of course, if they come up, and I'll get to them most likely at the end. All right. So what are we going to talk about today? So I want to talk to you a little bit about the evolution of the DBA role to start, because I kind of see people pitching this idea of AI DBAs, and I think there's a lot of nuance to what could or couldn't work there. I might have some strong opinions, but I'd be happy to share with you my perspective, and I think hopefully some of you share that perspective. I think there is a problem with today's Postgres MCP servers. There's a security problem, but I think there's also an abstraction problem. So I'll give you a few examples of the MCP servers that exist today that can basically enable our AI tools like Claude to do better work, and why that may not actually be a good idea, especially when we talk about production. Then I want to show you the new pganalyze MCP server that's now in early access. If you're interested in early access, at the very end of the webinar, there's going to be a survey. And so you can fill out that survey and say, yes, I want to try it out. But I'll show you two different demos where first we're going to investigate a database issue with Claude Code and the pganalyze MCP server. And then we're actually going to combine the pganalyze MCP server with the Honeycomb MCP server, which is an APM tool. And I'll show you kind of how we can cross-reference APM information with database information, and why both are basically useful and really enable you to get to a good root cause analysis. And then last but not least, I want to talk briefly about agents. I'm not here to sell you an agent. Lots of companies sell you agents today, but I'm not interested in doing that. In fact, I think we should think about maybe building agents, but I don't think we should buy off-the-shelf agents, basically. But I will show you some examples. And one of the things that I also want to talk about a little bit is a customer of ours, Robinhood, published basically a case study of their own, a blog post last year, where they talk about how they built their agents and how they use pganalyze to power those agents. And so I want to give you examples of what you can build and where Postgres data and pganalyze data can be useful. And I'll end with kind of, what our vision, my vision is for where I think we fit in this world where, AI tools are more frequently used, and also some things that we won't change where, AI is probably not the right solution. All right. So let's talk a little bit about the evolution of the DBA role. So one thing that we often see, and this is, simplification, obviously, but when we work with large organizations, we see, this kind of pattern a lot, which is we have a small data platform team, a DBA team. Sometimes this is part of the infrastructure team, where you have people that have worked with Postgres for multiple years that have a lot of experience. And you have many more application engineers that work with those different databases that ultimately, these combined teams manage, right, and optimize. And so I think fundamentally we have a problem with Postgres expertise, right? There are not enough people that really know how to use Postgres effectively, how to tune Postgres. And so what ends up happening is that these application teams on the left here there's just more of them, right? They also have more knowledge of the applications, but they will always have a lack of expertise. And so to a certain extent, right, like if you think about this picture, there's this idea, well, what if we just had AI DBAs, right? Like, can we just replace the platform team? And I think that's fundamentally the wrong idea, right? I think like if somebody sells you an AI DBA, I think they're missing the mark, because it is not, in my mind, it is not about replacing people. It's about enabling the application teams. And so, if we think about, why don't we have OpenClaw be our AI DBA, right? Like, why don't we just let the agents do all of it? And I think the problem is, quality is an issue, right? Like, there's bad recommendations. And that has gotten a lot better, right? So like, I don't actually think that the knowledge itself is the issue, but I think the bigger problem is the risk and threat model just doesn't make sense, right? Like, we don't want to have the willy-nilly take actions automated DBA. And I also think that organizational knowledge does actually matter, right? Like if you have a production application, not something that's vibe coded, and you have something that you can maintain for many years, you do actually want organizational knowledge about certain things. Like, for example, if something keeps being a problem, you want people to know about this, not just the AI tools. And one of the things, kind of coming back to this idea is like, can we enable the engineers instead of replacing DBAs? I think, when I look at what AI does, right, AI makes it really easy to make reasonably looking but flawed changes. And sometimes they're not flawed, right? But basically, your problem is you don't know for sure. And so I think the problem is if we just auto-applied all these changes, we'd basically be overwhelmed fighting a fire hose of changes that weren't originally thought through. And Fred Herbert wrote a really good article about this where he basically talks about the picture they paint of you, where like in his case, it's the SRE role, right? Like this is not about DBAs, but about SREs. And basically a lot of people are saying, well, we don't need site reliability engineering anymore. AI can do it for us, right? And so I think Fred describes it as, the vision behind these AI SREs is that incidents and outages are one-off exceptions. We can just paper over them, right? Like just have the AI take care of it. And really what he's arguing for is that outages are a structural problem. They're a consequence of what you've done, and you need to learn from that, right? And so to me, when I think of that in this picture, it means we need to enable the application teams to work better, right? Like we need to enable application teams using AI tools to be more effective. And we still need that data platform team to be the ones that enable that, right? So if you are a DBA today and you're not in that AI world, I think what I suspect you'll find is if your organization pushes for it, right, it's like you'll be asked to basically enable those teams. And what that means is, provide better tools, provide better playbooks, provide better support and escalations, because there are going to be edge cases that you always need a human for. And in that moment, you want to make sure that your teams actually give you the right information so that you can act. I think, to me, again, it's about enablement, not about replacing the DBAs. This is a little bit of a long-winded quote, so maybe more interesting to read through on the slide copy, but there were also some studies done on cognitive depth, right? And this is an example of where a team basically really relied on AI tooling, and then the problem is they basically lost the sense of how things functioned, right? Like they just couldn't explain why design decisions has been made, how different parts of the system were supposed to work together. And so it wasn't a technical depth problem, it was a cognitive depth problem where they basically didn't have a theory of their application, of their environment. And so I think that's the other thing here is, right, like if we just let AI do things automatically, that doesn't really work, I think. And there was a question whether we're going to share the recording, and yes, we're going to share both the recording and the presentation tomorrow. So if you want to look through it or share it with somebody, you can do that, of course. And I also think this is just, as I've been researching and kind of evolving my own perspective, I think one of the things I've been thinking about is, should people still learn about Postgres, right? If I can just ask my AI tool, why do I even need to understand what Postgres is doing? And I think you'll find that people have different perspectives on that. But I think my perspective is it does matter to understand this technology that is, at the core of what your applications are doing often, right? Like if Postgres has a problem, you often have a production problem. And so I think if we get this right, like then, like Hazel had a good blog post about this where she was arguing about people can observe AI tools doing something and then you can learn via osmosis, right? So you can basically, you don't even necessarily have to be the one taking actions, which in production use cases, maybe that's not necessarily applicable, right? But basically, even if you vibe code something, or even if you vibe optimize something, observing what happens is actually very useful versus just, having it happen and not looking at it. And I also am a fundamental believer in this idea of computers can be understood that Nelson Elhadj kind of talked about, where I think, Postgres can be understood, right? Like that's one of the things why Postgres is such a great database is I can understand what it does. I can research it. I can go into the code. There are people who have done that I can talk to. And I think we need to make sure we don't lose that because that is what makes it a good production database. All that said, I think what's interesting is just in terms of knowledge is you can certainly encode best practices with skills, right? I'm not going to talk much about that today, but it's worth noting that different companies like Timescale, Neon, ParadeDB have published specific repositories of AI skills that will help your AI tools make better Postgres stuff. Like ParadeDB, for example, did that because they have some, extension on top of Postgres that does better text search. And so they want to make sure that if you write an application that knows how to interact with ParadeDB. So I think there are good ways to basically have these knowledge repositories. But we're not going to talk about that much today. I just wanted to point out that does exist too. One of the things that I've learned, and this is kind of, coming back a little bit now towards MCP servers, is AI is actually pretty good at tedious tasks, right? Like if you write, for example, an application and, you could have the AI code your feature and do full vibe coding, but you could also have the AI just help you write a test case. Like it's much easier, in my experience, for engineering, for software engineering, to write tests with AI because AI gets you over that initial hurdle where it's like just a lot of work. And so we think about that for DBAs, right? I think there are certain tasks that AI tools can really help us with. So for example, maybe it can help us do structured analysis, right? So it's not necessarily AI doing the full analysis, but it's us being able to pull the context in. It's us being able to maybe look at the explain plans in different ways, trying different optimization strategies. And then I think one of the key things that I found really useful, and I'll have a demo on that later, is researching application code, right? So if you are not on that team that's doing the work, but you are asked to basically optimize a query, being able to have a tool like Claude Code ask, hey, where is this query coming from? Where is this being used? It's such a multiplier in terms of effectiveness. Like it's unreal, right? But like that is, I think, something that a lot of people will benefit from, even if they don't use AI anywhere else. It's just as a research tool in unfamiliar environments. Cool. Let's talk a little bit about the problem with Postgres MCP servers, because I think they really do have a problem having looked at this ecosystem a little bit. So first of all, there's a lot of different Postgres MCP servers. So if you look for the Postgres MCP server, it basically doesn't exist. Anthropic created one about a year ago, but they basically said it's unmaintained. I think that's a good thing. I'll tell you that more about that in a moment. Like there's different providers, right? Like AWS published one for labs. LRDB has a built-in one now. There's DB Hub, which is kind of more agnostic. These are all simple servers that basically help you execute queries on your database. And I'll get to that in a moment, but please do not run that on production against your production database, especially with write credentials. Like MCP servers are not, like these are risky basically, right? So like this can be really dangerous in terms of what happens. So I think in practice, if people are using these today, they're going to use them against their staging and dev environments because I don't see how they would use it in production. There's also what I kind of like to call the do-it-all MCP servers. So the ones that I'm aware of is pgedge's Postgres MCP server and Crystal DBA's Postgres MCP. Those basically have a long tail of more sophisticated features that are not just about run a query or get schema information, but it's more about help me get some recommendations about my database, like all kinds of things, right? Now, looking at a couple of these, and the one that I did not include here was LRDB's MCP server, because LRDB's server is part of the offering. And so, I couldn't look at the source to understand easily what was going on. But for these 5 servers here that I looked at, there's a couple of key functionalities that I would expect there to be, right? So like you can run a query because all these are intended to run queries. You can, in some of them, run a explain, which I think is really interesting. And all of them have some way of getting schema information. And then some of them have additional capabilities like getting docs, like pgedge has a Postgres product, right? And so they basically let you search the knowledge base about Postgres and pgedge's Postgres product. I'm not sure if that's really a good thing these days. Like a lot of people, I think, have either separated this out into separate like knowledge MCP server or just use skills for that. So we'll see. The thing that really, negatively surprised me is basically do not trust these servers with, doing stuff in a safe way. And this is my analysis, over probably a day or so. So, don't basically, if you are one of these authors of these servers and I'm misrepresenting that, I'm sorry, I'll be happy to adjust it in the slides, but I think it's correct. So basically all these MCP servers have an ability to run a query, and they have different safety measures to enable read-only mode. And the problem is the only one that I could find that maybe was safe here was Crystal DBA's Postgres MCP, which I'm not guaranteeing that. I'm just saying it looked like it was doing more than all the other ones. So the worst cases here are, I would argue, DB Hub's MCP server and the AWS Labs MCP server, surprisingly enough, because both of them look at the query that is being passed to that MCP server, and it's checking for keywords, and it's doing that in different ways. But for example, DB Hub's just doesn't check for write CTs, right? Like I can write the statement as like with, and then I put an update statement in there, and that would just happily fly through. In the AWS Labs case, they were a little bit better, but they also missed some other things like execute statements in a do block, I think. So it's basically like be really careful there. And even if it says read-only transaction, think about multi-statement strings, right? Like if you do like a query that's rollback, semicolon, other query, like I think definitely that was a problem in Anthropic's original MCP server. And I think it's also a problem with pgedge's MCP server, at least from my read of the code. So just tread carefully in terms of what they promise around read-only. The other thing to say on maintenance is look out for, are these servers being maintained? The best example, of course, being Anthropic's original MCP server is not maintained anymore, so don't use that. Crystal DBA was acquired in 2025 by a company not doing Postgres things, so I'm a little bit skeptical, although Johan, who's the founder of Crystal DBA, seems active on the repository. So I think maybe that's being maintained. Maybe there's some new stuff coming there, so that's good. And pgedge, for example, DB Hub, these seem maintained and actively developed. Important pause here, right? Like if you want to make something safe in some way or form, like say it's read-only, always do that on a database, right? Like don't rely just on the MCP server, because Postgres has an existing, role-based access control mechanism. It has roles like PG monitor, PG read all data if you want to do that. And you can do that on the Postgres side. And then if the MCP server only has credentials for that, that is a good guarantee that you can't actually mess with the database. So I would say, don't trust an MCP server. Even if you write one yourself, it's hard to get right, basically. And yeah, Benjamin had a question there. Should we create an MCP server for a specific user? And yeah, that's right. That's what I'm thinking. Like basically, like think about, for a particular database, what do you want the AI tool to do? And then create a user that has exactly these permissions versus just giving it your super user access or even, just a regular database owner access. The other question that I would ask here is, right, like, why can't we just use pSQL? Because, we like, why do we even need an MCP server? And a lot of people are talking about CLI tools are better than MCP servers. And so, I was like, well, let's see what Claude has to say about this. And so Claude is actually happily telling you to do that. So if you ask Claude, how can I run Postgres queries from Claude Code? It will tell you to just, pass the pSQL stuff along. And it's taking a little bit of, kind of prompting to really get to the point that it's maybe a bad idea. Because the thing you got to be careful with is if you put credentials in an LLM context, right? So if you make a tool and you say, here's the credentials, like you just paste it in and say, connect to my database. The LLM has it in a context. And so if you then do something else, open a Jira ticket or something, it has the opportunity to use that credential that you used earlier in the session if it was in the same context. Obviously, today's models are much better at not doing that, but I think it's still a latent risk. And we basically with credentials, we cannot do 99%. We have to be 100% sure that stuff doesn't leak. And so that means, if you want to do something with pSQL, for example, find a way to not pass the credentials like the pgpass file, or maybe write the CLI tool as a wrapper, because that's what makes it safe. Now, I think all of this is, great, but I think the problem really is, I think realistically, most of you here today are not going to do that, because if you want to access production, somebody, probably your InfoSec team, will say, that's not a good idea. We're not going to allow you to use any Postgres MCP server or even pSQL to connect to a production server from an AI tool, right? Because it's just too risky. Like the threat model is not well understood. These tools are brittle, broken, unmaintained in many cases. And so I think I'd be surprised if, more than 1% of people here actually had a working AI tool connected to production use case, which is a problem, right? Because this is a challenge for real world debugging. There was a question from Nicholas if I looked at the Microsoft Postgres MCP server. I have not. So I have not researched that. I think the same challenges apply. I would basically check for what is it doing? What are the credentials? Can you limit to read only? But I haven't looked at Microsoft's MCP server. So yeah, the problem I think today basically is people will not have this connected to production, right? And I think part of the reason is that we're not doing well at differentiating which level of access we want to give these tools, right? Obviously, in the top of the ladder here is destructive access, right? Like it can write to the database, it can run DDL, it can, do messy stuff. Next is, I think, unrestricted read access, which is actually very problematic too, because again, you can leak context, you might access data in unexpected ways, you might have sensitive data in your databases. And so I think for production is also going to be tricky to really do that well. And then there are a couple of things that I think are actually useful, and I'll show you more about in a moment. But, if we think about, for monitoring specifically and for optimization specifically, I think there is a way to basically make sure Postgres gives us the right permissions, in a restricted way. And then all that the MCP server might be doing, or the environment that the MCP server is running in, is to filter it. Or, if you want to go really, aggressive, you just say metadata only, like I just want to know which tables exist. So before I move on, there was one more question which I think relates to the existing MCP servers. So Anand asked, Google is providing an MCP server for its database services like Cloud SQL and BigQuery. Is it safe to use that with an production environment? And I think the answer is you should look at it and understand it. I'm not going to give you an authoritative answer, I think. My understanding is that at least the LRDB MCP server that I looked at was not very clear on what permissions you're giving it. And along this ladder of, which layer of access, it wasn't clear to me whether it was read access or destructive access or none of the above. And so I think staging, yes, right? But production, I would have a lot of hard questions for Google, basically. And the same goes for Microsoft's MCP server, for example, right? Just make sure that they explain well to you along these layers of access. What is the server actually doing? Which user is it using? How can I restrict it? How can I log it? What it's doing? Things like that. So yeah, I think for today, I'm really interested personally in this monitoring and explain perspective, right? Like how can I get enough to debug production issues without, going full read access or full write access? So to me, this is a problem of, we need a better abstraction here, basically, right? Like we need better user, of course, but I think also, if you think about which tools we want, right? Like we want things like for performance optimization specifically, we want, query performance statistics from PG stat statements. We want to have wait events. We want to have slow query plans, explain, analyze. We want to have schema information is quite useful, right? Like knowing how large a table is on production or how large an index is. And sometimes system metrics are also useful. Like if I had an issue in production, I want to know that did something spike, right? And so, basically, I think what we shouldn't be doing, right, is we shouldn't be doing this, which is we shouldn't be connecting our production database directly to an AI tool, even if, there's an MCP server directly sitting in between. I think it's practically speaking, that doesn't work for production, right? Like, I don't think it's a matter of just putting a better MCP server in place. For me, it really comes back to this idea, and this now is focused on performance optimization. Like this doesn't work for other cases, but if I'm like performance optimization or incident investigation, really what I need is I need some kind of repository that knows what happened on the database, right? Like some kind of database for a database, basically, which, if you think of traditional infrastructure monitoring, like if you have Grafana, for example, Grafana can be that, right? Like it, or like, CloudWatch, right? So it's about, what is this intermediate that has enough information about what happened, but it's not the actual database. And this is part of why I'm here, with pganalyze, because pganalyze has a role to play here. Pganalyze can actually be that piece in the middle, but I'm not saying you must use pganalyze. Like you could use something else here too, right? But I'm saying this abstraction matters because you don't want to just pass the raw data through. Like there is a filtering you want to do. There is maybe some overtime information you want to do. And so that's just tricky to do. All right. Now I want to share something which part of why we're talking about MCP servers is because we actually saw a pganalyze customer do an MCP server themselves. And before I jump into details on what they did, Robinhood being the customer, this is all public information, so I'm not sharing you anything private here. You can find this as an article on LinkedIn that Ashwin from their team published. But one thing I want to point out, right, is like in this article where they talk about their MCP workflows, they have pganalyze in the picture, and pganalyze represents that workload repository, right? So it's basically that piece in the picture that makes it able for you to do things without connecting to the database directly. And so in this picture, pganalyze is the part that talks to RDS and Aurora. And then Robinhood basically went and created their own MCP server, because at the time we didn't have an MCP server ourselves. And they built their own agents that connected to the MCP server. So yeah, we didn't actually start out writing an MCP server, right? Like it's the fashionable thing to do, but we didn't do that yet basically at the time. And so back in November, Ashwin from Robinhood basically published an article where he was talking about, how can they bridge the infrastructure teams, environment experience with AI tools. And so they are basically, pushing on an MCP powered ecosystem internally. And so this, very nice detailed article, we'll have a few details on that later. But just coming back to, why did they use pganalyze here? This is all original from the article, is, they wanted to make sure that it doesn't, fetch user data. It doesn't, have access to sensitive information. pganalyze can redact PII. And you don't actually want the LLM tools to run stuff on your database, right? Because that has performance impact too. Again, not saying it must be pganalyze, like you can use other tools, but the point is having something that is in the middle that can give you that information is really key. Yeah, let's get practical, right? Like let's talk about what we can offer here. So, and again, I'll try to keep this, grounded, not kind of just selling you on it, but really telling you what works, what doesn't work in my experience. So we're excited to introduce the MCP server as part of pganalyze. This is a new MCP server that is not what Robinhood built. Robinhood built their own basically on top of our API, but we basically are now publishing an official MCP server or making available an official MCP server. And so the way to look at this, right, is like the pganalyze MCP server is, part of pganalyze. It's a server-side MCP server, remote MCP server. And so you can enable that. And when it's enabled, your AI tools can connect to that, and they don't have to talk to the production database, but they can get certain information from production, like which flow queries happened and such. This is still evolving. This is an early access, so don't quote me on this in a couple of months. But the key tools that we found useful so far is we built tools to fetch query information, table information, wait event information, like what connection spikes happened. And then the really interesting stuff I think is when you get down to the explain plans, right? So we have a tool basically to fetch an explain plan for a query, and then also a separate tool to fetch an explain plan from a trace span. I'll get to that in a moment with the kind of APM demo, but I think that's where I lit up and was like, oh yeah, this is actually really good. It's actually better than what you could do before. So, and I see there's a couple of questions that folks asked in the Q&A, so I'll get back to these later. One more thing that I want to mention here is one thing that we've done in pganalyze for multiple years now, and I think it's actually a really key thing to do, is we filter out PAI. What we mean by PAI filtering is mostly parameter values, right? So if you have queries in Postgres, parameter values can be problematic. And so with the PAI filtering, we basically filter out, if you have a where clause and it says, where insurance number equals some value, you would still see the column being searched for, but you wouldn't see the actual value. And so I think this is part of the puzzle to make this work well, right? It's like we have to be sure that the LLM doesn't see the PI. And so pganalyze already has that built in when we get the data in the first place from the database. And a couple of principles that, I think are important to how we think about this problem, right? First of all, control, right? Like if we call LLMs, they should ideally be in your environment because you know what is, like first of all, then you process the data. So you know exactly, where it gets sent. And you can always turn it off, I think is important, right? Some people don't want anybody in their engineering organization to use an MCP server because of risks, basically. So control is really important. I think authorization is important, right? So like I think to make this work well for production use cases, we need to focus for most part on what the user is able to see, right? So if I'm on my laptop running ChatGPT, for example, and I want to talk to my database, basically, whatever happens should be a subset of what I am allowed to see, not, kind of a broad default permission because an admin clicked authorize somewhere. And they should be able to filter out data, and it should in fact be filtered out by default before it gets past the LLM, right? So I really got to make sure that the information that gets fed back is, statistics, metadata, but not actual end customer PI. Cool. Let's jump into a demo and kind of look at, some practical things here. So this is all real stuff, real data that I looked at yesterday, but I did copy to the slides to, not make it too brittle, and LMs are prone to change what they're doing, so it's always risky to make a demo directly, but these are all just one-on-one copies from what happened. So we're going to start with investigating production database issues, and I'm going to use Cloud Code. I found Cloud Code to be really good as a tool myself, and I think many others in the industry have found that too. So this is, recent Cloud Code release. We have a couple of MCP servers connected here. For this first demo, it's just going to be the pganalyze MCP server, but we're also going to show the Honeycomb MCP server in a moment. Now, I'm basically starting with asking a very broad prompt, which is, my production database is slow. Why, right? And you could formulate this in many different ways, but like basically, might say my production database is slow at 5 p.m. Show me the activity there. But let's suppose, it's slow right now. Why is that? There's a couple of, aspects here is like which database is it, right? So I think if you have many teams, potentially, configuring the context to be specific to your team's server is useful. But in this case, we have one main server. That's production server is the prod.db main server. And so the MCP tool can basically pull up information from pganalyze. One thing I've always found really what I like about Cloud Code is that it's reasonable at asking for permission, right? So a lot of people say, well, to be productive, you have to, give it all permissions all the time. I don't think that's true for investigations. I think you can easily just approve individual tool calls. And so here in this case, we can actually say, well, I want this to fetch the information. So now we're fetching, query statistics, we're fetching some of the issues that pganalyze detects. And then, one thing that LMs do like to do is, or the way the model is trained basically with the reinforcement learning, is it does like to jump to conclusions. So always take this with a grain of salt, right? But for example, here, with the data from pganalyze, it was able to say, okay, on production right now, there's, query that, runs average 2.7 seconds. It has certain buffer cache hit ratio. And, it's able to get all that context, right? Now, if you didn't have an MCP server with production access, what would happen is it will probably tell you to run a query, right? So if you didn't have the MCP connected, you would give you, run this query with pgstat statements. But then the problem is, again, you would have to go to production, copy and paste things. B, you would have to audit the output to make sure you're not copying anything sensitive. In this case, we basically used pganalyze as the clearinghouse to make sure this is safe information. Then we also have missing index information pulled in, right? So one of the things that, like thinking about, what's the role of advisors, right? Like pganalyze has an index advisor. We've worked on that for many years. Is that still relevant in the LLM world? And I would argue yes. And the reason is because it can run in the background, right? It can run all the time and tell you things proactively. If you do that with an LLM, it's going to be really expensive, and it's probably going to optimize on local maximas versus the big picture. But I can pull in this information from Index Advisor, right? So I can see the fact that Index Advisor has some tables that were flagged with missing indexes. And then, this is all still part of Cloud's output. Basically, Cloud's analysis is, address the scan, look at these missing index recommendations, investigate things. Now, what we did in this case is we drilled further into the query explains, query explain plan. It's a little bit of a meta thing, I guess, because this is the pganalyze application itself that we're looking at. And so we're basically saying, let's look closer into this. This was me basically saying I want to see the explain plan. And give me a moment. And so what we can do with this, right? And this again is where I think getting the right level of production data is so important. Now we can actually have the LLM pull the individual query plans for that query. And you kind of couldn't do that otherwise, right? Like, I mean, again, if you ran this without an MCP server, it would probably tell you to do explain analyze. Then you would have an explain plan with all sensitive data in it. And so the nice thing here is that because pganalyze has PI filtering built in, it was actually able to pull the plan, and I feel confident giving it this plan, right? Because this is, already filtered, and I know that the data in the pganalyze UI doesn't have the sensitive data either. And so in this case, it's pulling the explain plan. You can see the query here that's representing also has, the parameter values removed. And then it's able to basically, from the pganalyze MPI, pull the text for the explain plan and kind of show us, what happened, right? And so this is, I think, where if you had a human doing all this work, that also works, right? The human would probably do the exact same thing. But I think this, like when I think about, enabling different application teams, I think this is where if you have a regular run-of-the-mill application engineer, they might struggle to get to this point, right? Like they might not even get to the point where they get the explain plan because you got to click in the right place, you got to have the right things set up or paste the right things and interpret it. And so I think this can be really useful if we get them, the slow explain plans basically in an easy to access way. Now, there was another thing that Claude had mentioned here, which was, there were issues with snapshot cleanup, and Claude was suggesting, let me just go back to show you that. So if we go here in the middle, like on the third piece, it was saying, investigate the snapshot cleanup spikes. The delete cascade could be causing lock contention. And I think this is, again, another point where we shouldn't just trust it all to the AI tools to figure out, because this could be causing lock contention if I have observability stuff set up, right? Like I can know whether it's lock contention or not, because I can measure the wait events, I can measure the blockers and the Postgres queries. And so this could be something we want to investigate. And so the way we can investigate this is, is there any evidence, right? Like we can ask, do you actually see this happening? And so it's checking basically, there was a major spike of a query. And so then the conclusion is, well, actually, there's no lock contention, which is what I would agree with, because there were no events at all that were waiting for locks. And then I think the correct conclusion here is IO was saturated, right? There was just too much activity. And, that's kind of going into the wait events and saying, well, you had lots of data file reads happening. Again, this is where, you can get all this data from the pganalyze UI today, but cross-referencing it and being like, oh, let's just look at the wait event. Let's just look at the wait event for those queries. I think this is actually genuinely useful for both for me as somebody who could do this himself manually, but also I think for people who are maybe more novices and don't know that they should look at wait events. I think that's where the AI tools can really pull in that context for folks. We can pull explain plans for, any of these queries if they're in pganalyze. I can also do comparisons. I think one interesting thing is we have a comparison feature in pganalyze, but the LLM could also do that. I think what's interesting though is like, let's say I run this in my session, right? I come to the conclusion, well, maybe the slow execution is because there are many rows being fetched. If I can, then get a backlink to pganalyze, I can actually record that as evidence, right? I can say, well, we had these executions, they have the same plan. Here is the conclusion of this investigation. And so I think it's, even though we can do a lot of this work in a tool like Cloud Code, the fact that we get backlinks into the tool that has the record is actually very useful for, knowledge sharing in the team and basically taking actions. And same, we can do plan comparisons. We can also just get the individual plans. And again, I can just ask for the link and I get the backlink to pganalyze. The other thing that's kind of magical, and I think that is why I actually do think this is a good direction for us to go as teams that are trying to make Postgres work better, is I can really easily get an understanding of where query is coming from. This is one of the most common problems, right? Is like you have query activity on the database and you don't know why the application is doing that. And so here in this case, I just asked where in our application is the slow query originating? And then Claude was really good at this. And it's to the point that I'm like, that doesn't actually make sense. Like, why would it know, right? Because it's only read one file. It knew to read the delete old snapshots file and says, here's the query. So you would think that it's the model being really smart. But That's not actually fully true. The model is good at picking up details, but the reason that we got this information was because we added query tags into the query comments, basically. Sorry, we added source locations into the query tags, right? So query tag is basically a special comment you put in the beginning or end of your query. And the query tag can say things like, it's this background worker, it's this line of source code, maybe it's this trace ID, but it's basically context from the application side. And certain frameworks like Rails 7.2 actually has built-in support for that. You just have to enable a flag, and then it adds those source locations as comments. And that is super, super useful, because that way Claude can jump to that directly, as can I as a human, right? I can look at this and I can be like, yes, this comes from delete old snapshots line 92, but then Claude can actually go and pull the code, right? Because you run it, like in Claude Code's case, you run Claude Code inside the application, the repository, inside the directory. And so it can actually look at the ORM code and say what happened, right? And I think this is the, if you only achieve this, I think you'll have saved so much time, basically, from, investigating slow queries. So I think this is a key thing to do and to enable. Let's do one more demo, and then we'll talk about a few more other things and wrap up. So when we combine the MCP servers across different vendors, I think that's really interesting, right? Because, in the old world, you would have, dedicated integrations, and you would have things like webhooks, and those things still matter. But I think with, an AI tool driving and you connecting to different things, you can actually connect across the different kind of data sources. And so here in this case, I'm starting this investigation with asking about slow requests and asking about traces. So we use Honeycomb at pganalyze. Honeycomb was a great product. They basically built an APM tool that, is like kind of uses OpenTelemetry tracing data in a really good way, has lots of customizable way to do reports. And so in this case, we have, the information in Honeycomb that we're interested in. Now, pganalyze has a way to integrate with OpenTelemetry compatible providers. So if you're using Honeycomb, if you're using Datadog, if you're using New Relic, we can basically hook up with those, and we can make sure there is a link between the trace information and the pganalyze information. We'll see that in a moment. This is all Claude, theorizing about, okay, the app is GraphQL based, log statistics would be a GraphQL operation, blah, blah. And now we found the GraphQL operation. Now we're still in Honeycomb data. We're finding, slow traces. And then in this case, we're finding that this log stats GraphQL operation was slow. That has, max latency of 25 seconds, P95 of 4 seconds. It's pretty slow. And so in this case, Honeycomb's MCP server is also pretty good at showing you evidence, right? Like giving you those links back to Honeycomb, so you can be sure that this is the data. And then the theory here is, okay, well, it looks like, that select rows statement is slow. Now, if I just stopped at this, right, my problem is I have a slow query, but I don't know why it's slow, right? And so if I ask, can I get an explain plan for this 18-second execution, then we basically get into the point where it can pull the pganalyze tools. And so we have a dedicated tool called get query explain from trace, which is able to resolve the tracing span information that we put in with our OpenTelemetry integration. And so this basically now takes the APM information, the specific trace, and goes to pganalyze and says, can I get the query explain for this trace? And so now you actually have the APM. Well, the APM tool doesn't have the data, right? But we have the data in our local session, and we basically are now able to have the analysis across the slow trace combined with that explain plan, again, from the production data. So this, just cuts a lot of investigation work down significantly. All right, that's it in terms of demos. Now, I want to briefly talk about a few more things, and then we can do Q&A. What about agents? Like, everybody talks about agents, and we're still talking about agents, and, I don't know if in 6 months we'll still be talking about agents, but there's some interesting stuff there, and there's a lot of people trying to sell you something. Again, I'm not trying to sell you something. I'm just trying to tell you what I think is useful and not useful. And one of the ways we can look at this is we can look at what Robinhood did with their MCP server and their agents, because I think I always like to see what is actually working for people, right? And so in that blog post that I published, they talk about 2 different agents they built. They talk about a PR review agent, which basically looks at pull requests and is able to analyze the migration. And then the way that the pganalyze MCP server comes in, it's able to know the size of the tables and the size of, the existing indexes, which is something that, matters, because if you looked at this just in the, local def database, the tables are small, but with the, actual production information that the table is large, we can now, have this agent mark it as high risk, for example, because the migration involves a large table. The other thing that they built, and this is, I think pretty straightforward, is basically a Slack storage assistant. Storage is the internal team, basically, that, provides tooling for other teams. And so in this case, what they did is basically have this assistant pull data. And so you can ask that assistant, what are the top 5 largest tables or what are the slow queries? And it can answer that. And so you can easily interact with it through, a kind of customized prompt that makes sense for them. So now it's important to note that these are all, things where, it's still, roughly the user driving it, right? Like a PR review, for example, is still user initiated. And so what they basically learned from this is that, it really helped increase developer velocity, right? Like it reduced the operational burden on that central team because other teams can now do more analysis themselves. And then also PR reviews, like where the storage team was involved, was cut down significantly. So this is, real life data that this works for them across many, many different teams. Now, the other agent that exists, and I've not used it myself much, just so you know about it, is the team over at Zata. They created an agent that basically does investigations using LLM-based playbooks. And it's somewhat active. I haven't really used it much in production or seen it used much in production, rather. But just be aware that this is, I think, one of the, like if you look into Postgres world, this one exists, but I also think it's kind of falling short on actually being that useful. But I think it's a good example of what you could do if you basically just had LLMs, run in the background looking at your database. And for me, the question is, can we do better, right? Like what can we do about this agent situation and what can we automate basically? And so I think about this kind of as there's an autonomy problem with agents, right? Like this exists for like code writing, but it also exists for database optimization. And so I would argue that, on the right side, we have no autonomy, and the left side, we have full autonomy, meaning the agent just does stuff for us. And I think most organizations, for good reasons, are on the right side of this graph, right? They don't let agents just run willy-nilly doing things. I think PR reviews are a great example of where, an agentic workflow makes sense because it's still, an engineer doing something, and then PR review is just looking at stuff. And so pulling in more information from a database there, it seems very reasonable, I think. Same for incident investigations, right? Like you could argue that, if I suspect the database being a problem, firing off an agent that investigates for me seems useful. I think next step up the ladder, and that's, I think, in my opinion, still useful, is the automated testing of optimizations, right? So if I have a suspicion that like creating an index makes a difference, I should test that, I should verify that. Why not have an easygoing workflow that the agent can do for me, right? So I think there's a sweet spot there that could make sense. Then we have the extreme, which is just directly take action on production, right? Like the same way DBA oftentimes has actual production access, let's just give it to the agent. Clearly, we're not there, right? So, the risk here is, my DBA agent took down production, right? Like that, if you just let OpenClaw do your DBA work, then, that's what would happen. And so clearly we cannot do that. I also think that there's a middle ground that's a little bit problematic, which is you're doing stuff what the agent told you to do or the LM told you to do, but it's still slow, right? And this kind of comes back to this problem of cognitive depth. Like if we're basically just passing off all the stuff, that actually doesn't work. Like you can't just, expect it to magically do stuff for you. And now how can we build agents that actually make sense, right? And I'm saying this as somebody who has not created an agent myself yet, but I've observed other people talking about what works for them, and I'm basically trying to map this to the database world. And so one of the things that Michelle Hashimoto, who was one of the HashiCorp founders, talked about recently, talked about this concept of harness engineering. Basically, the idea is if you see an AI do a bad thing, try to give it better tools that it could have called out to prevent or course correct bad things. And so I think one of the things, right, like how do we move from, the no autonomy to the full autonomy? To me, it comes back to this, like we need to find the right abstraction. We need to find the right information, the right tools, because that's how we basically get more autonomy, is by making it specific, right? And so I think those tools should be owned by the database team ultimately, right? Or the storage team or the platform team. Like those teams are responsible for providing better tools with the input from the application teams. The other thing that's, interesting here is this idea of agent back pressure, right? So like if you have some kind of feedback mechanism where like in a software use case, it would be pre-commit hooks, test suites, linters. But like if you give that to an agent, that actually lets it move forward, right? And so in the database world, I think that's around, can we do an explain analyze? Can we, enable database testing on clones? Like Aurora has a good clone feature. If you use Neon, they have cheap branching, right? Like so there's lots of ways that you could have an agent basically test things out and that way iterate on a problem. And I'm going to go out here and basically, and I can do this because we're not venture funded. So, if we had a VC breathing down our neck, they would say, why are you saying this? But basically, I think vendors like to sell one size fits all agents because they're good for the stock price, right? And if you're VC funded, it's good because you can get more VC funding. But I don't think that's going to work. And I think we're in such a noisy environment, like it's not actually useful to buy an off-the-shelf agent from a vendor, I think. I think that if you are on a platform and engineering team, you should be the ones creating these agents, designing these agents, setting them up. Whether you ultimately go buy it from a vendor, that's up to you. But I do think that whatever a good agent is, I think it's probably not one that you buy from a single vendor. It's probably one that you customize and that you make work well for you. Again, for MCP servers fit in is they can give you this information from the different environments you work with. But basically, I don't think you should expect that you can just buy an agent and be done with it. I don't think that's the right way to think about it. Okay, let's spend a few more minutes and then Q&A shortly. But let me just tell you briefly where I think pganalyze fits in this picture, right? Because we've been in the space for a while, we've seen many different changes, and we care about building the best tools for Postgres. So what do we think makes sense here? So at its core, I think about pganalyze as being the best Postgres-specific monitoring, analysis, and recommendation tool, right? So pganalyze is good at capturing Postgres data. It's good at telling you why something is slow. It's good at helping you do root cause analysis, and it's good at helping you do index recommendations, for example. We very intentionally are not using LLM-based advisors, which is actually still a good thing, right? Like it's important to reconsider, well, with the models being so much better, should we just run an LLM to do index recommendations? In our experience, that does not work well because LLMs are not good at looking at the big picture. They're good at the individual, I'm looking at a one query type problems. And so the way we look at this is the core of pganalyze will most likely, for the foreseeable future, not use LLMs in the core product. Rather, what we want to do is we want to enable you or other companies to create AI tools that can interact with pganalyze. That's really where the MCP server comes in, right? So now this MCP server that's in early access, you can now basically connect your third-party agent to that, right? And so when I say agent, that could be something that's not really autonomous like Cloud Code, or you could keep calling Cloud Code in the loop, I suppose, or you can build something yourself that makes sense for your environment. Maybe you have your own PR review system. You can now hook pganalyze data easily into that, right? We might in the future have some pre-built pganalyze agents. I think this is where I'm looking for feedback from what people actually want to buy, but it's not off the table that we can give you a pganalyze PR review bot that is an agent of sorts. I'm very skeptical on again fully self-tuning, automating databases. I don't actually think that that's a good direction. What I do think is interesting though, and this is really more of a tangent here, is I think there's a space for automations, right? There's a space for enabling better ways to not have the database do stupid things, for example, or to re-index things automatically. And so I think none of this has anything to do with LLMs really, right? Like it's just a question of setting up a schedule and running some checks. But the LLMs could potentially help you configure the automation, right? But the automation itself, I think, should always be deterministic. And so when we think about, where do we see the future going, it's really not all about AI, right? Like AI is here to stay, and we want to make sure that if you use an AI tool, we can enable you to use that effectively. But we're actually on the big picture, we're less interested in that. We're more interested in, what are the key challenges that make Postgres hard at scale? And so these are things like plan statistics, right? Like detecting plan regressions, managing plans, like preventing bad plans from happening in the first place, building other Postgres specific tools, allowing more customization options, right? Like with Index Advisor, maybe, I can have the LLM provide some input to Index Advisor, but it's still running our own constraint programming model in the background. And we have some more work coming up this year on, fleet management, other purpose-built visualizations, right? So we think all of that matters because in the end of the day, you still need, a reliable source information, a reliable place to go about what's wrong with your Postgres database. All right, and then, last but not least, the pganalyze MCP server is now in early access. So if you are currently using pganalyze or you are interested in trying it out, the post-webinar survey that you'll see, it will also send out, has a question on, are you interested in early access? And then if you say yes, we'll reach out to you and we can discuss next steps. Wonderful. Well, thank you so much for joining today. We have a few questions that I'm going to get through. And if you have more questions, feel free to put them in the chat. And then we'll also send out the recording and the slides tomorrow, as mentioned. All right. Let's see. So I think some of these questions were from earlier. So like time travel back with me. So Gabo asked the question on Postgres MCP servers. He was basically asking, could you create an MCP server for Postgres to iterate with an open source AI model like Olama's models and such? And of course you could, right? So I think the model you use actually doesn't really matter that much, right? I mean, the quality of output, of course, does matter in terms of which model you use. But I think if you wanted, like if, for example, in your environment, you don't want to send anything into a cloud LM model, you could use any MCP server that you think makes sense fully in your environment with a local model too. But all of the problems around data access still apply, right? So like you still have this problem that a local model is still going to leak context, for example, right? So if you have your production database credentials in there, it's still going to do things in a way that's not really safe. And then Nicholas mentions that Timescale has an option for zero copying, which lets you simulate a production database. That's basically, I think very similar to what Neon or Aurora's cloning offers, right? So to Nicholas' point, I think that really basically makes it easier. Like the challenge, right? Like if you have an agent that's trying to optimize something with the pganalyze data, for example, it would know what's happening. But then the question is, how can I try something out? Like if I create this index, what happens? And so I think it's really important to have some way of doing copy of your database or clone of your database. And so I don't think you need to switch providers necessarily for that. Like if you are on Aurora has that built in, for example. Regular Postgres, not necessarily. But I think we'll see more tooling, including from pganalyze, to make use of these clones more effectively. Then Michael had a good question. What if I create a proxy for the MCP server, like I assume a generic Postgres MCP server, and review or approve every single SQL statement that it wants to run, right? So like if I'm sitting in the middle, basically making sure that nothing bad happens. And yes, that of course could work, right? Like if you have an approval workflow and you should also look at the data being returned because again, the context can leak to something else in the conversation, but you totally could do that. I think probably people will find that frustrating to work with, right? I think that's part of the reason, like it's very compelling to have the AI do stuff for you and not be asked questions all the time. Like there's a tendency to like switch into auto approving stuff. And so that's why I'm a little bit cautious to say that's a good idea because I think people tend to at some point just not do the safety checks anymore if they're too much work. So. And then, yeah, Michael basically says, could that be safe for production? And I think the answer is it could be, right? Like, I think it's a question of then, do you trust your operators who operate the LM tools to check every little thing always? Okay, let's see. Oh yeah, Benjamin had a good point. So in the earlier output that we saw from an LM, Claude was suggesting to use a generated column, and the generated column, when you create that, could require table lock, right, and could cause issues. And so that's actually a good point because in the earlier example, right, these recommendations, they all were just Claude theorizing, and so you could probably, ask it like, oh, is this a big table? And it will tell you, oh yeah, I checked pganalyze and it's a big table. I shouldn't, do the statement that's causing issues. But yeah, that's the issue of interpreting LM output. Like it looks correct, but like you actually do really have to dig deeper. Let's see, a few more questions. Probably take 5 more minutes for questions. Let's see. Okay, so Zuri had a question. If I have a multi-tenancy setup with one database per tenant, right? So each customer has their own database, and I build an agent, one per tenant, that corresponds to each tenant's database. Could I use an MCP server to lock that to that database? So I think what you're asking is like, could I design it in a way so that it's clear that it's not leaking across customers? And I think the answer is you probably could, right? Like I mean, it's ultimately this technology is still like it has logic to it, right? Like I mean, it's not just magically doing stuff. Like it is like the context that you pull. Like if the tools you provide are all from that customer and you don't have any other tools that go across customers, you should be able to still have tenant data isolated. But you really got to be careful, right? Like this is where like once you start mixing the same MCP server for 20 different customers, like then it becomes messy basically. But I think you could, like if you're careful, you could do it. Yeah, and Roberto is just supporting the people are saying things are slow and they don't know why, like that being a common thing that customers tell Roberto. And I think the Roberto basically says most customers that he talks to don't actually have regular monitoring, not even AI tools. And I think like that is part of why I think we need tools plus AI to interact with them. But if you just have the AI, again, it will just tell you to run queries, and that doesn't actually work that well in practice. Let's see. We'll do 5 more minutes for questions and then we'll wrap up. Emil had a question. Have we considered adding MCP resources for evaluating pganalyze or Postgres configuration? For example, if the server is missing information from sources like auto-explain, could, the agent basically say, oh, I've done all I could, but if only you enabled auto-explain, then I could give you more information. We've not looked at that specifically. I think it's a good point, though. We probably could surface that more clearly in the kind of the metadata we return on server. Like if we think the server is missing the auto-explain configuration that we recommend, then we could probably use that as a way to make sure that you actually have a good experience. And there was a question, so Bapi asked the questions, are there plans to integrate LLM tools with workbooks? So workbooks, just for context, I haven't talked much about them today, but workbooks are a pganalyze feature that lets you run a query first of all, it's a way to run explain analyze in a structured form, right? It's like instead of having just individuals running explain analyze, it's a way to record a test of a query, like an optimization of a query. And so to Bobby's question, right, do we have plans to integrate LLMs with workbooks? And the answer is yes, we do. It's a nuanced conversation, right? Because workbooks and pganalyze are actually a way to test the query, and we have an optional workflow called the collective workflow, where pganalyze can actually drive the explain analyze for you. And there are a bunch of privacy and security aspects to that, which is part of why I didn't demo that today, because I feel like there's more nuance to making this work well. But if we make that work well, right, what that enables is you can actually have your LM tool, you could ask it, can you optimize this query? The LM could spit you out and explain analyze to try, and you could actually execute that through pganalyze in a safe way without leaking problematic data or causing production issue. So more on that to come, I would say. Let's see. I think there are a few more questions. Okay, let me take 2 more minutes and then we'll see if there's too many questions. We can also do a follow-up. Okay, Suri had a question. In a use case where users write custom SQL, but the custom SQL may not always be well written, could we use pganalyze MCP server to rewrite these queries? And I would say not in the current version, like we're not kind of taking arbitrary queries as input, but it kind of comes back to a workbooks question, right? Because I think this idea of I'm iterating on a slow query and I'm rewriting it, that's why we created the workbooks feature in pganalyze. And so I think there's something we can do there, but if you're interested in that, happy to set up a conversation and we can kind of explore that more. Mehmet asked a question, can I get recommendations for Postgres parameters with pganalyze MCP server? Only to the extent that pganalyze makes them today, right? So pganalyze, for example, has a vacuum advisor. The vacuum advisor looks at, your configuration settings. And so if the vacuum advisor flags something as a problematic setting, like for example, you're not vacuuming aggressively enough, the vacuum advisor will make that recommendation in the background. And then when you talk to, the pganalyze MCP server and you say, oh, is there any problems with auto vacuum? It will actually pull that information. So if there's an existing advisor for this, yes, but not necessarily for arbitrary settings. I kind of find that it's also a little bit overvalued in terms of settings tuning. Like that doesn't always make that much of a difference in Postgres. And then Sai asked a question, how will an agent be able to learn a new version? I assume a new version of Postgres. It's a good question. I think ultimately, I think the best thing here is that, the models just get updated. I mean, you could always be like, here's, the skills that are, the updated knowledge base for Postgres 18 or 19. But yeah, I think it's kind of, you probably, if you're on the bleeding edge, which for databases we often aren't, right? Like Postgres 18 is out, but most people use Postgres 16 or 15. And so the models know really well about those versions. So I don't think keeping up to date is as critical, actually. All right. Well, in the interest of time, I think what we'll do is, and maybe actually, yeah, I think why don't I get back to the rest of the questions by email? So basically, if you have in the follow-up, you'll get a summary of all the remaining questions asked on probably one of the slides, so that then, if you had a question and I didn't get to it, I'm happy to talk about it async as well. Great. Thank you so much for joining today.